Hi, my name's Peter O'Shea. I'm the owner of American Dry Basement Systems, and I'm here on location, and what I'm going to be covering today is a basement slab, a basement floor that has a whole lot of cracking going on in it, and the best way to handle that when you're waterproofing your basement. So we have an enormous amount of floor cracking. If you look, the cracks go this way, it goes over to the wall. It comes this way, it goes to the wall. Another centerpiece goes to the wall. If you look here, there's kind of like an island where it goes like a diamond and comes here where cracks go all around it. It's like a little separate spot, like an island right in the center here of cracking. If you take a look at this crack, you can see it's what we call clamshelling. In other words, the crack has gotten wider. It's not because the floor has just pulled apart evenly. It's because something has pushed up from underneath, cracked the floor, and it clamshelled up and out like this. That's how you can tell it was cracked, by water pressure, by hydrostatic pressure underneath the floor, pushing on the bottom of the floor, and if you think about it, lifted the floor up and caused it to clamshell. It's important to remember that concrete's very, very heavy. So a square foot of concrete to 4 inches thick is just about 50 pounds. So if you look at the area of a basement, figure out what the square footage is, multiply it by 50, and by 50 pounds, you're going to get how much concrete floor is down here. In the area that we're in right now, there's probably between 55 and 60,000 pounds of concrete floor. You really want that floor to be on that ledge, being supported and not being supported by that soft soil that's underneath the floor. That's what will occur if you put the type of system in that removes the floor off the footing. The floor now is going to be settling and moving and sinking and doing things, and this cracking issue is just going to become much more pronounced, much worse than what it is right now throughout the entire area. What often occurs with basement foundations is you'll get wall cracks. Now, what causes a wall crack is that the area on the outside of the wall is the backfill area. It's usually about 6 or 8 feet wide. That was empty all the way around the entire house when they originally were building it. It was backfilled in, and that soil that they brought back in, it was originally in this hole, but when it was brought back in, it had already been rolled over and bulldozed and piled up. It lost a lot of its density, so when it's used as backfill to put on the outside of the walls, it's a good bit softer than the existing soil, the undisturbed soil out there. And when you get heavy weather, that area fills up with water, and it puts an enormous amount of pressure on the walls. And the way a wall releases pressure is by cracking. So then you have to do a crack repair. And there's different ways of doing it. This was done by another company. And basically, instead of repairing the crack, what this is a patch where they just came up to the crack and put something over top of it, came all the way down and patched it all the way to the floor. And then they chipped out the floor and set it up so that there was a little bit of drainage area underneath the floor for any water coming through the crack that would hit the patch, run down the patch, and then fill up underneath the floor. The reason this is a bad idea is that you have hydrostatic pressure, especially in this particular type of foundation. If you look at the cracking in the floor, you have clamshell cracking, which means water pressure has pushed the floor up and actually cracked it, because you can see that clamshell, it's coming apart like that, which means something pushed from the bottom. So water, when they got heavier rains, came up through the area that they set up to collect the water from the wall. What they did was they just made the path a whole lot easier, because this cement, I've seen these before, is going to be about 1 inch thick, 1.5 inches thick, and this actually allowed water to pour up through and come in around the edges and help flood the basement, along with all the other ways that water was getting in. Let me see what this patch is like. So we have kind of a rubbery membrane, and then they put something absorbent on here in order to actually hold some of the water. If you can see, they've really done nothing to the crack. Wow, the crack has been left completely untouched. There's no repair of the crack whatsoever. It's strictly just a patch. There's definitely things you don't want to do when waterproofing your basement, and this absolutely is one of them. Yeah, there's nothing all the way down the entire crack. There's no patching. This little stuff sticking on here was just part of that sponge that they put on there that was supposed to absorb some of the water as it came through and then hold it up against the wall, which is probably about the worst idea that you could have when you're trying to repair a crack. Well, we've torn the patch off of here and we're going to repair this wall correctly, get in there and actually reconstruct and make it structurally sound again. The thing about wall cracks is they usually come in pairs. We call them sister cracks. There's one here and there's another one directly across from it on the other side of the foundation. That has the same kind of patchwork fix to it. This particular crack, they did the exact same style as over there. They broke out a little bit of the floor and had this patch go down so the water would fill up in the patch and run down and fill up underneath the floor. When speaking with the customer was explaining that water was just bubbling up and pouring up through where this particular fix was. The same way that we repaired the one on the other side, we're going to do the crack injection and then use our proprietary products of Supercrete and Super Slurry, which will grow into the concrete around where we crack inject and completely repair the entire wall from inside to out. When you have a whole lot of cracks, you need to keep the structural integrity of that floor intact. That means the floor's got to stay on the footing and up against the walls. So what we're going to do right now is we're going to mark out how we're going to leave pieces of the floor intact, and then we're going to take pieces of the floor out. So we're going to design the whole system right now with a trusty piece of chalk. We have a nice sized crack right here. So we're going to remove this part of the floor because it's already broken. So what we're going to do then is design out where the spacers would be most appropriate, where they would do or have the best effect to give the most support to this floor. So as we come across here, we're going to leave a spacer here. So this will be intact. That floor will be intact. We're taking a piece out here. We're getting up to a place where there's a real significant crack in the wall. Another company did a patch job on it, which was completely ineffective, and it kind of corresponds with a real major crack that's going along here. With this type of situation, how you install your waterproofing system has a lot to do with keeping all of your structural integrity together with your foundation. We're going to remove this part, and when we put concrete back, we're using a really strong concrete with a crystalline ingredient that actually will grow back into the main body of the floor and help with this big gaping crack that we have along here. So this is going to come out along with where the patch is and right along here. And then we're going to put another spacer, another engineering tab, if you will, here. Continuing on, we have another crack along here, and we're going to leave another spacer here. It's extremely important that we keep that floor periodically on that footing as we continue around. The last thing we want to do is remove the floor off the footing over a large span and then not have the proper support underneath the floor. If that occurs, the weight of the floor can cause cracking. So we're going to keep the floor on that footing. If it's on the footing, you're just not going to get that floor cracking. So we work our way down the wall and we're able to leave a spacer underneath where the hot water tank is. Rather than have to move it, our spacer serves two purposes. It allows us to keep the water tank here and also keeps that floor, a nice large piece of the floor, on the footing and holding the walls out. Now, as we work around the corner, we have another obstacle. The furnace acts as another spacer, so they're going to come here and leave an area here to here as another spacer, keeping that floor, the structural integrity intact. And then we'll work our way around the corner in front of the Bilco doors, and then we're back to where we started with the engineering tabs. Now we've torn off the covering, this patch for the wall crack. Now there's a waterproofer out there who claims that he wrote the book on basement waterproofing, and this is his technology. And if you go through the book and you apply it to how it really should be done, just about the entire book falls apart as far as the right way to do it. And he never ever gets into how to handle a specific type of foundation because a lot of his methods are cookie cutters and it's one size fits all. And when you have a cracked floor like this, the last thing in the world you need is a cookie cutter. So I'm going to show you right now, as far as if you were to write the book about basement waterproofing and how to fix cracks in walls, I'm going to undo one that was done, and let's just see what the thinking was, what the psychology was around it. Because if you take a look down here, we've pulled the patch off the wall, they broke out the floor, they put a little piece of what they use for their drainage in there, but it doesn't go anywhere. It just sits there to accumulate a fixed amount of water. And if you get any more than a very tiny bit of water that would fill up this little track here, it's going to come out onto the floor. Now, the customer complained that water was just bubbling up out of this whole area when they would get heavy rains. So let's see what they had. We've taken the patch off. Let's see what's underneath here. Of all the things I've seen in basement waterproofing, this is as far-fetched and as ludicrous as anything I've ever seen. I've never seen anything more ineffective or poorly designed that just wasn't thought through, which falls into what a lot of waterproofing ends up being is make it look good no matter how bad it works. But this is never a way that you'd ever want to spend money in order to repair a basement wall crack. And if you noticed how weak and how flimsy the concrete and how easily it came out of the crack, that's because of the type of patchwork that was done here. This is absolutely the worst possible scenario, locking water up against the wall, holding it as water's coming through a crack. This is the next step of the process. We've chiseled out all of that deteriorated concrete from that patch holding the moisture in up against that wall for an extended period of time. We got down to all really good solid concrete. We had to chip out a little bit more in this particular crack than you normally do just because of the previous attempt to patch it. And we've drilled the wall and put in our grease fittings. Now, a grease fitting is a fitting that has a gasket on it. So we drill the hole, we put the grease fitting in, and then we tighten the gasket, and it causes the gasket to expand, and it holds extremely tight into the hole that we drilled. And a grease fitting is just that. We take a grease gun and we put it on the end of the grease fitting. We're not pumping grease through it, we're pumping a hydroactive gel. And that gel goes through the crack, and you've noticed we have grease fittings periodically going up the wall, and it will go through the crack from inside of the wall all the way through to the outside and expand through the crack. And we expand it through the first fitting and then to the second fitting and then to the third, and expands all the way up, but it also expands from the inside of the wall all the way to the outside of the wall. Now, what we're brushing on the wall itself and into the crack is super slurry. The super slurry has a crystalline ingredient in it that actually grows into concrete. It crystallizes through all the porous nature of concrete. Concrete is like a slow sponge. It absorbs water because it's porous. The product that we're putting on there right now gets rid of the porosity. It fills up every nook and cranny that concrete naturally has and turns it into a waterproof membrane. The other thing that the slurry does is it activates the concrete in and around the crack. So we're going to be putting our Supercrete product on as a finishing cement, which is going to grow around the hydroactive gel seal from inside all the way outside the wall and actually encapsulate it, and it turns this whole strip of wall actually stronger than the uncracked, regular, undamaged wall. So, and then we're going to leave it with a nice clean finish, but both products have that crystalline ingredient which grows right through concrete, gives it an extremely strong, structurally sound finish, and water just can't possibly get through it when we're done. Okay, we finished. We're at the last step. We're just going to take the tape off. So we've covered this. We've chipped out the wall. We've put our grease fittings in that we use to pump our hydroactive gel. And then we slurried in around the crack that activated the concrete. And then we put our SuperDry product in that grows around the seal, our hydroactive gel seal, and has turned this whole cracked wall into one solid pillar, where this is now stronger than the other uncracked parts of the wall. If this wall were to break, it would break somewhere else rather than here, because this now is the strongest part of the entire wall, inside to out. This is the second crack in the foundation that we've been working on. It's another patch. So I'm going to tear this off. And if you can see, there's this sponge thing that's on here that basically holds the moisture up against the wall. As we saw in the other crack, it deteriorated the concrete significantly to the point when we were chipping out, a whole bunch extra concrete came out because it was so deteriorated. It was so weakened. So this is actually a sponge that holds the moisture. Last thing you want to do is hold moisture up against a concrete wall. Concrete needs to breathe, and this is the exact opposite idea. There's no breathing where this was covering the wall. So it locked all of that right in and actually caused more harm than it did good in its attempt to fix the cracked wall. And then we're back down here. This all went down, and we'll see how this looks in here. So this goes down, the sponge is soaking wet. So it just wicked the water down, and there was no place to go. I guess this was supposed to be kind of a catch basin. But if it was, they removed part of the bottom of it, and it sat right there. And once again, you can see they only put back about an inch of floor. So super important point is that we want to get back that proper thickness of the floor. Magic number is 3.5 inches. We have plenty. We have plenty here. We have plenty here on the side of the spacer. And as we go around and test, we have plenty of floor that's going back, completely code compliant all the way around the foundation. We've put our super slurry up 24 inches up the wall. That's going to grow through the wall from the inside to the outside and turn that whole portion of the wall non-porous, so it can't absorb any water. As we go down, we have our pipe and stone. We'll just take a look to see where our pipe is. We'll dig down, and you can see we have a whole lot of stone in there. And then we're getting down to the top of the 4-inch pipe, which is also on top of stone. So we've created around 10, 12, maybe even a little bit more inches of drainage way below the bottom of the floor, as opposed to the other ways of doing it, where the drainage sits right here, and the water's got to completely flood this high around the whole floor before anything gets to the drainage. Create that low spot, drain the water 10 to 12 inches below the bottom of the floor, the entire floor stays dry. What we've also done too is with our engineering tabs, we've kept the full body of the floor on that footing and then still holding the walls out and in place. And we're going to re-cement with our SuperDry product back to the full thickness of the floor. It's a whole lot more work, but it's the right way to waterproof your basement. The most important aspect of any subfloor water management system is the pitch and placement of your pipe. It's got to be pitched, but it must be done so in a way that it always stays within the depth of the footing. We need to break the basement in half when you have a good sized basement, and we'll pitch that pipe one direction around to the sump station, and on the other side around to the sump station, and then we'll have a second sump station in larger basements on the far end, and then we'll pitch from that point around to that sump station, and we'll pitch the pipe on the other side around to that sump station. So we optimize how much pitch we can use within the limited amount of footing that we have. But what we're doing is we're creating that low spot that's going to be 10 to 12 inches below the bottom of the floor. That's key. We call that the magic zone, that area within the depth of the footing that water has to rise up underneath your floor. We just manage it at the bottom of the footing so that it never gets anywhere near your floor. So if you have any questions or concerns about your basement, by all means, give us a call, or you can go to our website, americandry.com, and you can always leave a question in the comments down below, and we'll get back to you as soon as possible. So, till next time, have a dry basement.